Tektron began manufacturing atomic absorption spectrometers soon after Dr. Alan Walsh invented the technique in the early 1950s. In 1963, the AA3 was the first completely Australian-made AA spectrometer. Many generations later, the range of Spectra instruments was introduced to the market. Tektron moved to its present location in Mulgrave in 1967.
Hello, I'm Helen Milty. Soon after moving to this site, Tektron merged with Varian Associates, a high-technology company in California. All of the instruments are completely designed and manufactured here in Melbourne. Varian employs over 400 people, and some 95% of production is exported to all parts of the world. The development of a new instrument begins with product specification by the marketing department. They consult with customers and the sales force to determine what functionality and features the instrument should have. The design of the new instrument then begins in the Development Engineering Department. A sophisticated CAD/CAM system is used to create and test mechanical designs before parts are made. Parts for prototypes are made by the skilled tradespeople in the model shop or directly on production machines. The model shop is for the exclusive use of the development teams. Prototypes are evaluated and tested in an area affectionately known as the Bronx. Individual component assemblies are life-tested to ensure that they will survive years of typical use before needing maintenance. Software engineers are a critical part of the instrument design. They write the software that drives the instruments and handles the data. Prototypes and instruments are put through strenuous environmental tests. This includes testing the instrument at the extremes of electrical power inputs. Temperature and humidity are also changed to represent the wide range of environments that the instruments may be eventually subjected to. From the heat and humidity of a copper mine in tropical northern Australia to the extreme cold of a Siberian winter, the instruments are designed to keep on working. A major part of the design of a new instrument is the evaluation process. The instruments are evaluated by qualified chemists who ensure that they meet the specifications to which they are designed. These chemists represent the final customer who will use the instrument. All new instruments undergo a drop test. This involves transporting a packaged instrument on the back of a truck for several hours before being dropped onto a hard surface. If the instrument is still working to specification, it passed the test. Using team engineering, the instrument design is transferred from the Development Engineering Department to the Manufacturing Engineering Department. This ensures a smooth transition into production. Using the CAD/CAM designs, the sheet metal components for the instruments are punched, bent into shape, and painted in the sheet metal area. Other metal components are made in the machine shop. The automated CNC machines can hold up to 122 tools at one time. This reduces the setup time and keeps batch sizes to a minimum. As part of the Quality at Source program,
testing equipment is located close to the machines so that the operators can check their own work. The optical castings for the instruments are machined in the machine shop. These components, along with 5,000 others, are controlled by the Kanban system of just-in-time manufacturing. The flow of inventory is centrally controlled by a barcode system. The operators add or deduct stock as parts are made or used. The just-in-time system ensures low inventories so that when quality problems occur, they can be quickly rectified. The printed circuit board area makes the boards and looms for production. The bare boards are prepared before being loaded at the contact loading stations. The robotic station presents the correct component to the operator from a store of 1,480 components. The boards are then wave flow soldered. Components which cannot go through wave flow are added manually. The boards are subjected to stress to induce any short-life component faults. They are then component tested and finally tested in an instrument before reaching assembly. Board production is also controlled by the Kanban system. The demand from assembly dictates which boards are made next. Varian Australia has a wealth of optical engineering knowledge. Using sophisticated software tools, new optical layouts can be designed and tested on screen. Optical components used in instruments, such as mirrors and gratings, are coated here in the optics lab. 8 coating units are used to meet production needs. All of the hollow cathode lamps used in the atomic absorption spectrometers are manufactured in the lamp shop. Glass blowers first mould the glass tubing into shape. The lamps are then assembled and tested before being transferred to a storage area for shipment to customers. Previously, production was driven by a monthly forecast, which meant that instruments were matched up with orders before shipment, so changing options or models was very difficult. All instrument systems are now built to order. This has been made possible by the just-in-time manufacturing system. Production schedules are determined only 5 days before shipment, allowing maximum flexibility and responsiveness to customers. All of the assembly work is driven by customer orders. Working in parallel, an instrument which contains 40 hours of labour can be assembled and tested in 16 hours. Because the instruments are built to order, even the language requirements of the customers are known. Sub-assemblies for the instruments are put together at dedicated workstations. All the components are stored close at hand. At the same time as the sub-assemblies are being put together, the optical chassis of the instrument is being assembled. The optical components are carefully aligned and tested before being placed in an instrument. The instrument comes together on the assembly line. Each operator removes the instrument from the line to complete their tasks. After the instrument has been assembled, and again before final testing, it is vibrated for 4 minutes. This ensures that it will survive a typical journey to the customer site. The instrument undergoes a series of performance tests before being shipped to the customer. These tests require the instrument to meet factory specifications which are much tighter than the specifications quoted to the customer. Any faults found are classified A, B or C class. Any A class faults, those that cause the system to fail safety or specification tests, are dealt with immediately by the A team. This is a group of specialists who are required to meet and solve the problem as soon as it is raised. To ensure that the instruments work as well on the customer's bench as they did at the factory, automated testing software is sent with the instruments. At installation, the tests are performed and a copy of the results is sent back to the factory to be compared with the original test results. As part of instilling a quality culture at Varian Australia, every employee is undertaking continuous improvement process training. This ongoing program complements previous quality programs and empowers employees to make changes to their work practices to improve quality. To monitor the improvements made throughout the company, many graphs are publicly displayed. For example, the number of complete shipments made on time is plotted each month and is currently over 95%. Varian Australia also continues to improve on its response time to customer orders. As well as the major instruments, Varian Australia manufactures a large range of accessories and instrument spares. The accessories extend the functionality of the instruments and allow them to be tailored for particular analyses. All of the components used to make the accessories are located on the shop floor. These computer-controlled carousels allow many parts to be stored in a small area. When the instrument is complete, it is delivered to the stores area. The instrument is then packed for shipment. The instrument is flown to its final destination, where it will be unpacked and installed by a Varian service engineer. Varian Australia continues to support their customers many years after the initial purchase. They guarantee to supply spare parts for a minimum of 7 years after an instrument model is out of production. They also publish many application-specific articles so that the customers can get the most from their instruments. Varian Australia relies upon the teamwork and initiative of its employees. After nearly 4 decades of building instruments, they're sure to be around for many more.